In this video, we are going to see more chemical properties of alkenes. So, here we are going to see the second chemical property. The first one was addition reaction of alkenes. Now, the second chemical property is oxidation of alkenes. So, the second chemical property is oxidation of alkenes. Now, here first we have oxidation with dilute aqueous KMnO4, potassium permanganate, and this dilute aqueous KMnO4 is also called Bayer's reagent. So what is Bayer's reagent? Bayer's reagent is dilute aqueous potassium permanganate, and we know the color of potassium permanganate is purple in color. Now this can also be taken or written as a test for unsaturation. That means test to find out the presence of double or triple bond. So this reaction with Bayer's reagent can be taken as a test for unsaturation. Now, how will you use this Bayer's reagent as a test for unsaturation? That is, alkenes on reaction with Bayer's reagent, that is dilute aqueous KMnO4, will give vicinal glycol, and this is used as a test for unsaturation as the pink color of KMnO4 get decolorized. So, when you add Bayer's reagent to alkene, what will happen if it's an unsaturated compound? The pink color of KMnO4 will get decolorized. So, that is the test, okay, for unsaturation. Pink color will get decolorized, and that is the observation of this test. Now, the product is vicinal glycol. Vicinal means the functional group attached to adjacent carbon, and all is alcohol functional group. So, vicinal glycol means OH group attached to adjacent carbon atom is vicinal glycol. Now, I'll write the example. Now, let's first write an equation for the oxidizing property of KMnO4. KMnO4 plus H2O. We get the product as 2KOH plus 2MnO2 plus 3 atoms of oxygen, and this oxygen helps in oxidation. Okay, and this KMnO4 will get, this is an oxidizing agent, KMnO4. It gets reduced to MnO2, and MnO2 is brown in color. So actually that pink color of KMnO4 gets decolorized, and in the test tube we will observe a brown color, that is the formation of MnO2. So this is the reaction for the oxidizing property of KMnO4, that is KMnO4 plus H2O. Dilute aqueous KMnO4 will get reduced to MnO2 by liberating 3 atoms of oxygen. That oxygen, 3 atoms of oxygen, that nascent oxygen, that is responsible for the oxidation of alkene. So next I am going to write the example for oxidation of alkene with Bayer's reagent. So the first example is CH2 double bond CH2. Now you can see plus H2O plus O. This came from KMnO4. H2O plus O is coming from KMnO4. Now dilute KMnO4. So sometimes in complete the following questions, H2O plus O will not be given. Instead, only dilute KMnO4 will be given above the arrow. Now, what is the product? Here we can see the OH bond. OH group will add to double bonded carbon. So, what will be the product? CH2OH, CH2OH. Now, this is a vicinal glycol, and the name of this compound is ethane 1,2 diol. There are 2 OH group, and if there are same functional group coming, then we have to retain the last E of the alkane. So ethane E must be written. hyphen 1 comma 2, 2 OH group, so diol. Now next example is CH3CH double bond CH2, propane plus H2O plus O in presence of dilute KMnO4. Now here also the double bond breaks and OH will get added to carbon atom. So what will be the product? CH3 CHOH single bond CH2OH. Now the name of this compound is, there are 3 carbon atoms. So 1, 2, 3. This is propane. Let's try the name of the alkene first, followed by the position of the OH group, followed by diol. So this is propane 1,2-diol. Now next one more example, that is CH3, third example. CH double bond CH CH3 plus O. Suppose you see this. What is the meaning of this O? It is oxidation of this butene. The product will be CH3 CHOH CHOH CH3. So what's the name of the product? The product will be butane. Let's write the name of the alkane first. 2, 3. From any side, left or right you number, both carbon attached functional group get the same number. So butane 2,3-diol. So this is the oxidation reaction of alkene with dilute aqueous KMnO4. You get vicinal glycol as the product. Now next we are going to take another oxidizing agent B with acidic KMnO4 or acidic K2Cr2O7. Now K2Cr2O7 is potassium dichromate. So these are the oxidizing agents, potassium permanganate and potassium dichromate in acidic medium. Now let's see what are the products of oxidation of alkene with acidic KMnO4 or acidic potassium dichromate. Alkenes on oxidation with acidic KMnO4 or potassium dichromate gives ketones or carboxylic acids. Ketones or carboxylic acids. These are the products formed, ketones or carboxylic acid, depending on the nature of alkene. Now, to find out what is the product form, whether it is ketone or carboxylic acid, there is an easy way. The way is this: if the double bonded carbon atom has a hydrogen atom attached to it, then the product formed will be carboxylic acid. Otherwise, the product formed will be a ketone. So that is the way to find the product of oxidation of alkene with acidic KMnO4 or acidic potassium dichromate. Double bonded carbon has hydrogen attached to it, then the product formed will be a carboxylic acid, or else the product will be a ketone. Now we will do examples for this. Example. First example, CH2 double bond CH2 plus 4O in presence of KMnO4/H plus. KMnO4/H plus denotes its acidic KMnO4. So here the product will not be alcohol, it's acidic KMnO4. So the product will be what? The product will be acid or ketone. Now let's see how to write the product. Look at the alkene, the double bonded carbon carries hydrogen. So we get two products, one from this side of the double bond and the other from the other side of the double bond. Now since the double bonded carbon carries hydrogen, we get carboxylic acid as the product. So here we have this side only one carbon, this side one carbon. And what is the acid with one carbon? It is our methanoic acid. So what will be the formula of the product formed? HCOOH plus HCOOH. One HCOOH comes from this carbon and the other one came from the CH2. So what's the name of HCOOH? It is our methanoic acid, or the common name is formic acid. Or you can write 2 molecules of HCOOH. So this is our first example. Now the second example is CH3 CH double bond CH CH3 plus 4O KMnO4 slash H plus. Again this is acidic KMnO4, and here you can see on either side of the double bond the carbon carries hydrogen, so we get acid again as the product. Now from this side we get which acid? CH3 COOH, acetic acid. Now here also we have 2 carbons, so again the product that we get is CH3COH. This is our ethanoic acid or acetic acid. Now the next example, example 3. CH3 CH double bond CH2. Now it's just given KMnO4 slash H plus. So again when you see KMnO4 slash H plus with an alkene, it is acidic KMnO4 oxidation is taking place. Now here you can see this side we have CH3CH. So again this carbon, double bonded carbon carries hydrogen, so the product will be carboxylic acid. So CH3COH. Now this has only 1 carbon and it carries hydrogen. So what will be the product from this? It will be HCOOH. Because there is only 1 carbon, we get an acid with 1 carbon. Now this is ethanoic acid and HCOH is methanoic acid. That is example 3. Now example 4. We have CH3C CH3 double bond CH2. Now K2Cr2O7 slash H plus, acidic potassium dichromate. Now here you can see this side we have no hydrogen on double bonded carbon, so we get ketone as the product. Now what is that product? Ketone CH3 CCH3, no change here. Here we will have a double bond O. Now this side CH2, we have the double bonded carbon carrying hydrogen, so carboxylic acid is the product and only 1 carbon, so the 1 carbon carboxylic acid is HCOH, formic acid. Now the name of this ketone is propanone, or the common name is acetone. This is 1, 2, 3, CH3COCH3. Now next example, example number 5. We have C double bond C, CH3, 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 CH3 plus 2 atoms of oxygen in presence of KMnO4 slash H plus. Now here you can see on this side we have double bonded carbon with no hydrogen, so ketone is the product. So how will you write the product? CH3 CH3 double bond O plus this side also you can see the double bonded carbon carries no hydrogen, so again ketone is the product. So what will be the product? CO CH3 CH3. Both products are the same, propanone or acetone. So these are the different examples for the oxidation of alkenes. Now next we have next reaction, that is number 3. That is polymerization. Now what do you mean by polymerization? Polymerization is the process in which large number of small molecules combine to form bigger molecules of high molecular mass. and the small molecules are called monomers and the big molecules are called polymers. So how is a polymer formed? When monomers combine, we get polymer. Now example, these alkenes can form alkenes. Large number of alkenes can combine to form a polymer. Example, preparation of polythene. Polythene is prepared from ethene. We know the formula of ethene, CH2 double bond CH2. Now, on polymerization, there are conditions which you will learn in 12th standard. Just write polymerization. Now, N molecules of ethene. Now, this is our monomer. Monomer means the simple molecule from which the polymer is prepared. Monomer, ethene, will undergo polymerization to give polythene. The double bond breaks and we get N molecules of polythene. This is our polymer. Okay, so these alkenes can undergo polymerization reactions. So these are the two properties that we discussed in this video, that is the oxidation reaction of alkenes and polymerization reaction of alkenes. Thank you.